Hi everyone, welcome to another Memgraph community call. So today we have an interesting topic, and that is how to build Amazon scale knowledge graphs for GraphRAG with Graph.Build. So our friends from Graph.Build will showcase their platform and how they use the platform um, to build the knowledge graph and kind of saturate the Memgraph with data. So with me today is Russell, software engineer working at Graph.Build. Russell, the stage is yours, and take it. Just for the context for our people joining live, you can ask the questions in the QA channel, and Russell and I will take it after the presentation.
Perfect. Thank you very much, Shanti, for that introduction. And yeah, welcome all to this Memgraph community call. I'm here with Graph.Build to show you how we can build an Amazon scale knowledge graph for GraphRAG. So yeah, my name is Russell Waterson. I'm one of the lead software engineers over at Graph.Build. And I'll be joined a little bit later on by Richard, who is the head of product, who will assist in hopefully answering some questions for you all at the end of the presentation. So the agenda for this call is essentially I'm going to give you all an overview of the Graph.Build platform, and then we're going to do a live demo. So first I'll show you the structure of the demo, an overview of the sample dataset that we'll be using, which is essentially a large dataset of Amazon reviews and product metadata. And then, yeah, I'll give you the live demo, and at the end, I'll answer some questions. So, starting with the Graph.Build platform architecture, this will demonstrate how we enable the graph development lifecycle through to the graph production itself. So firstly, we have the Graph.Build Studio. This is our no-code user interface for collaboratively designing your graph model and schemas, as well as interacting and configuring all the other components of the platform. You can imagine the Studio to be your graph model IDE and production tool. So next we have the transformers. The transformers are independent processors which take the model designs and makes the graph data. They can connect and ingest from virtually anything as a data source, whether it's Kafka for streaming, files of CSV, JSON, XML, or spreadsheets, any SQL database, and even RESTful endpoints. Change data capture, or CDC, is also supported by the transformers, and this allows your graph data to be always up to date and in sync with any changes made in your source data. The transformers can also perform any simple or complex data transformations via our plugins functions architecture. We have a large library of built-in functions with also the ability to write in and load your own for specific requirements that may not already be covered. And to complete the graph development lifecycle, we have the graph writer. So the writer will take the newly created graph data and write it to all graph databases compatible with the three most popular query languages. So Sparkle for semantic graphs and Gremlin and OpenCipher for labeled property graphs. And in this case, with Memgraph, we'll be utilizing Cypher. And all this can be done in either an update mode or an insert mode. So the Graph.Build platform is production ready. All the components are deployed as individual Docker containers, meaning the platform can either be deployed locally or on any cloud provider's environment. It also means that each component can operate completely independent of each other, catering for specific needs and use cases. Kafka can be used as the backbone to manage the entire data transformation and graph publishing process. And that's in addition to the REST APIs provided throughout the platform if you prefer a manual operation. And for convenience, you can choose to store all the platform configuration, the graph models, the graph data, either in S3 or on any local or network disk. So as for the demo, I will show you one loop around the graph development lifecycle using all the main Graph.Build platform components, where essentially we'll go from raw data at source to a fully published graph database. And to do this, firstly, we'll look at the Graph.Build Studio. We'll create a schema to define our data structure. And then using the schema, we'll construct graph models for our semi-structured transformer. And as mentioned earlier, these models are going to be based on some Amazon reviews and product metadata information, which we'll take a short look at in the following slide. And once we're tested and we're happy with these schema and model designs, we can put the transformer to work. So we'll trigger the semi-structured transformer to ingest and transform some of this JSON data. And given we have a Kafka service running, the graph writer will automatically be triggered and write our generated graph database, generated graph data to our Memgraph database. So a quick look at the data set. So on the left-hand side, we can see a snippet of our reviews information, as well as the product metadata. And in the middle, we can see the model which we hope to design, whereby we can see users can make reviews, and reviews are based on products, and products can also be a variant of parent products. And on the right, we can see a snippet of or a snapshot of what we can hope to achieve with the data loaded into Memgraph. So on to the live portion of the demo. So this is the Graph.Build Studio user interface home screen, where we have access to all parts of the application. So the model and the schema creation, the published schemas, where we can connect transformers, plugins, and also import and export user data. So firstly, we'll start with the schema creation. So this is an entirely optional step, but this has been a highly requested and useful feature, especially for larger organizations who want to have their data structures clearly defined. So here we have a partially created Amazon review schema, partially created so I can finish off and show you how simple it is to create these schemas. So we've already got our user, we've already got our review, we've already got our products and the connections between them. So let's create a parent product, which we can simply do by dragging in a node from the right and then giving it a label of parent product. And then drawing a connection between product and parent product, and then calling that is variant of. Same thing can be done for our properties. So review, we've already listed ratings, title, helpful vote, verified purchase, but we also obviously want the text of the actual review. So let's drag in a property, we'll give it a string, connect that up and say text. So this will be the review of the text. As well as dragging and dropping properties, we also have the tabular view, which I'll switch to now, which basically allows us to add in properties via this tabular view. Instead, if you have a data set with lots of properties, this can be an easier method of adding them. So throughout the studio, we also have full Git integration. So clicking this tab here, you can see the history of this model. So clicking through the history, we can see previous states of this model where we can either restore or we can make copies of and make edits on previous iterations of various models. The studio also supports collaboration. So this model at the moment is set to a private model, but I can also set it to be public or shared with specific users in the organization, and that allows for multiple users to be able to edit single schemas or models, as well as be able to view them being created live. Once we're happy with our models, our schemas, we can generate our schema and publish the schema. And this will allow these schema designs to be used for publishing, for creating our model designs. So switching to our semi-structured model, we can once again click onto this one that I partially created earlier. And as you can see, it's quite similar to the model screen. The difference being is we're now creating a model which will be used to transform our data set against a source. So switching to this tab, we can see this snippet of JSON, which is just a sample of the larger Amazon reviews data set. So here we can see ratings, title, the text, etc. And this gets translated into these input blocks we can see here, which we can then use to create our semi-structured model. So once again, we can drag and drop. So we want to create our parent product. So we can drag in the parent ID, select node, and then here we can select the label, which will be informed by our schema, which, as you can see here, has been selected as to help inform our model designs. And now we can select parent product. And now when we draw a link between product and parent product, it already knows that it's a variant of, as that was already defined in our schema. Once again, same thing for our properties. So we can drag in text, select property. We know it's a string. And then now when we connect these up, we can start typing text, and we can see here, this is taken from our schema. So now we finished creating our model for our semi-structured transformer. We can generate our model, and now we can test our model. And this will take the sample data set that we've provided and test it against this mapping that we've just created. And here we can see some output. So on the left, we have our nodes file. We can see this review, this 1-star review. This device I bought has brought my network to its knees. So probably not a device you want, but yeah, we can see the data has been transformed there. And on the right, we have the edges, so the relationships between each of those nodes. And this can be an iterative process. This testing model you can do as often as you want. So if you see something that's not quite right, you can jump back into the model, make changes, once again, test, and then you can have this back and forth process of slowly iterative. Once you're happy with that, you can publish your model. That will take the model and publish it to your transformer so that you can do full transformations in a production use case, which we will do now. So we can execute the transformer. In this case, we are hitting one of the exposed APIs for a direct transformation against the source. However, with larger data sets, like the full Amazon data set, which we'll look at later, the Kafka service was utilized to stream in large amounts of data. But for this use case, we'll have a specific file against a specific mapping, and then we can execute that. And as we can see, it's a successful transformation. We have 2 output files, a nodes file and an edges file, and that's been saved as individual files. And now that we have a managed Kafka service running, the graph writer, another platform component, will have automatically picked those up and then written it straight to our Memgraph database. So if we take a look at our Memgraph database, which was previously empty, I just have a simple select all nodes and edges query here, which I can run. And then here we can see some of our data has been inserted. So we have our users who have made reviews against products who have parent products. So yeah, this was just run against a local instance of Memgraph against that single file. However, a much larger data set of tens of millions of records has been inserted to a remote instance, which Antu will show you some hopefully interesting queries against. So yeah, that concludes the Graph.Build platform demonstration. How I've demonstrated one loop around the graph development lifecycle, for taking the raw data and then showing you how it can be easily inserted into our graph database. So yeah, thank you all for listening, and I will now pass you back to Antu.
Cool. Thanks, Russell. Give me 1 second. Yeah, so what I will share now is basically at the point where you have ingested something into the memgraph. On the last community call, our CTO started talking about atomic GraphRAG, which is essentially a single unified GraphRAG execution layer. I will bring you a kind of a short summary of that. The best way to actually learn about that is to go back and watch the actual community call. There you will see all the details around the atomic GraphRAG pipeline. So I'll just briefly kind of guide you to the process. So obviously, I know that Russell kind of mentioned it, but for those who haven't been on our community calls, Memgraph is a high-performance in-memory graph database that usually serves the real-time use cases. Very recently, there is a lot about context engines for AI, for memory layers, for structured knowledge. Like in this case, Russell showed the Amazon data set that was kind of previously loaded into the Memgraph. So what is essentially that atomic GraphRAG? So when you kind of start building some pipeline, you are essentially using a set of tools that you can kind of mesh together to build the pipeline end to end. And the idea is to have everything, all the primitives in Memgraph chained together to form such a pipeline in a single query. So essentially, in a technical sense, it's a set of Memgraph tools or primitives that enables you to build the whole GraphRAG pipeline as a single query. So, for example, as the Graph.Build has ingested the whole data set, now you can kind of query it on top of it with that atomic GraphRAG pipeline. But you don't have to specifically build a particular pipeline in some hard-coded language. Rather, it all executes inside of the cipher. So there are like different tools that enables that. Some of those are like shows schema info, direct embeddings on top of text, or complete nodes. That means that you can embed the knowledge on top of node and create a vector index that then utilizes that procedure essentially that was creating the embedding. So it's like in-place embedding. You can kind of leverage the search tools like text search and vector search. Obviously, the graph algorithms, so like deep path traversals, community detection, PageRank, depending on what you actually want to build. There's also from 3.0 LLM Complete, so we have added LLM API for making a summary of responses, so you can kind of create the whole summary on top. There's also server-side parameters. They will be added into the next release. They will enable essentially to have the atomic GraphRAG pipeline share the same parameters that are needed, so that the pipeline is like reusing the whole config within the different tools. An example is like creating an embedding to embed the actual node and then running the actual vector search on top of index. So you need to have the information about how big that embedding is. What we have been thinking so far about GraphRAG is essentially you have like this pivot search and then you have the relevance expansion, but the whole story is a bit bigger than that. So you essentially have more components on top of that. And they are driven by the three different questions. And by that, we define like three different atomic GraphRAG pipelines. And that's analytical type of query, the local type of query, and the global type of query. And that essentially defines the pipeline. I will briefly show you now each version of that pipeline, just so that you can kind of see how that operate in a moment. Let me just connect to the instance shortly. So we have the instance that Russell was mentioning. And what I can do now is just see like the data set. If you take a look, it's quite huge. So there's like 10 gigabytes of data. There is 20 million of nodes, 16 million of edges loaded, and they include like Amazon data set. So when we talk about like that analytical type of query, it says that it's an exact type of query where you asks for a specific type of data. So what would be that? So that would be like, let's find some kind of product, and let's ask, you're asking a specific question about some kind of specific product, like is there in the data set? So yes, there is a node with data set, and the pipeline, essentially the pipeline run that query, it fetched the data set, and that's the object that we have just seen. So that's the first version. The local would be like asking a question that would be like, is there are there like node that contains. So let's say that we add partial information. Now at this point we are referring to a particular node, but we are also referring to the nodes around it. But we didn't provide the whole information. So why is it critical? That's critical because in this case we are trying to find a particular piece of information and then the data around it. So it's not that we have provided like a specific thing, but rather we are trying to kind of gather something that is in the relation of the data. And usually that local search is kind of made of the pivot search and then relevant expansion. And the third version of the atomic GraphRAG is essentially a global type of thing, and that would be can you calculate the page rank on the subgraph from one hop or two hop, from let's say two hop. And that particular query is essentially used to get the data around that two hop query around that specific node. So we have like taking a global context into actual results and then returning it. So the point here is that you can build the whole atomic pipeline by just running a Cypher query. Obviously, now depending on the actual information or the question type, you can adapt the whole pipeline. So all of the things that I have shown you were essentially text to Cypher in this case. But obviously, if we had like a vector index or a text index on top of it, it would be the same type of thing. We would just ask something like semantically similar, like get all the products that use TV in their name or something like that. And then we would do a vector search, and then we would kind of hop and rank and return the result. Or for a global type of thing, we'll kind of do a grouping, or we will load some subgraph, create a summary, and then return it back. But all happening inside of Cypher directly on top of Memgraph. The important thing here is that the lab interface that I have showed you is essentially agentic runtime. What that means is that that's the experience you have like in Cloud Code, Cursor, and now in Memgraph Lab. That means that agent is essentially asking the questions, or not asking the questions, trying to figure out how to pick the tools that best serve the pipeline, and trying to find the path on how to build that atomic GraphRAG pipeline. So it's like maybe Cypher, maybe pivot search, maybe it's relevance, maybe it's vector search, maybe something else. But the point is, those are the three type of questions, and usually three type of pipelines that are built for that purpose. What is the difference? The difference is that in this case, so this piece of code, a Python piece of code, is computing a community summary on top of the data set. while this cipher is doing the same thing, but is doing atomic operation inside of the database and doing it on the transaction. So there's no pulling data out of the database and pulling data back in. So the bigger benefit is that it bridges the agentic write time, MCP, and the database. And when you kind of combine these tools, you get everything you need in the one single package. For those who don't know, we have a GraphRAG Jumpstart program. So if anybody is building with Graph.Build or wants to build with Memgraph, you can also use this link. And at this point, we are more than happy to take the questions. I will pull back Russell. And I will pull back Richard if it's here. Yeah, and let's answer to the questions from users. So I can see that somebody complained about the quality of the call. We'll take a look at that. Okay. So let's see if we have questions for you. Okay, so there's a question. I was trying to build comparable graph in a size to the Amazon scale with a lot of text with nodes plus embeddings. Like for the full review dataset, how do you deal with high memory requirements of the type of the graph? In my use case, I reached something like 150 gigs, which makes such a solution very expensive. Actually, this is for all in-memory databases. This is caused by the text saved in nodes between any plan to do anything. I guess this is question more for Memgraph. We are kind of looking into how to optimize the memory usage. One of the recent things in the 3.8 was we released the single vector store feature, which means that the vectors are only stored once in memory, which was not the case before. So if you had a lot of embeddings, maybe you should reevaluate with the new Memgraph, if that was the Memgraph case. So this would be like in some cases it can even be like 4x lower memory usage, because depending on how big the dimensions of the embeddings is. If it's low, it's lower the gain. If it's bigger, then there is a bigger gain on top of it. Yeah, I hope I answer, Andrea. Thanks for the question. So we have one more question. I'm assuming you are passing the graph schema tool and to give a cipher query. Yeah, that's correct. And the question is, if the cipher schema is too big, how do you handle it? Well, the thing is that you need to pick the schema based on the question you have asked. So it's kind of the dynamic schema loading and dynamic schema exploration. We started working on the tools for that, but they haven't yet hit the MCP so far. And the second question is, what is the current latency for end-to-end example I just showed? I'm not sure I'm referring to Graph.Build, but Russell, I guess when you're kind of modeling the graph, you're also taking into consideration how the import procedure works there. The transformations, I guess, are optimized.
Yeah, exactly. So the transformation process that I showed was with a fairly small data set of about 100 records, and you saw that was fairly instant. The 10 plus million was obviously a little bit longer than that, but yeah, the transformation was quicker than the write. I couldn't give you exact timings, but it was, yeah, done in a day for the entire transformation and publishing. And that included the designing of the schemas and the models.
I see. Cool. So that was the question that we just answered. Yeah, and if the question was end-to-end, yeah, I also showed the example end-to-end. I mean, the latency depends on the kind of the generation of the question also, and the whole Memgraph execution. But I was also showing the smaller on the smaller scale. But yeah, if you notice, the things went quite smoothly overall, so it wasn't waiting for anything. Do we have a starting tier for the startups? Is that question for Graph.Build or Memgraph? I'm not sure, but maybe Russell, you can answer for Graph.Build, and then I will for Memgraph.
Yeah, sure. So we have 2-week free trials. So it just enables you to get your hands on with the entire platform. So the transformers, the writer, as well as the studio. And then we have different tiers for single users versus multiple users versus enterprise. So yes, we do.
Cool. Yeah. As I kind of showed, we have that GraphRAG for enterprises. So it doesn't say startups, but I guess if you are building a POC and it is interesting, I think you should kind of fill out the form there, just so that we can see it and maybe we can build something together. On the startup side, we obviously provide a free license, so everybody can use Memgraph, so there is no like limits there. And we have free two weeks free trial on the cloud that I just showed you that can be used to build any kind of project. Okay, there is next question. How is the second name being passed? Let's say product name in your graph is MacBook, but the question you ask is Mac. How do you map the exact product? Okay, so I think that's the from the retrieval part. Or what do you think, Russell? Is that retrieval or maybe for the mapping of the schema?
I would
Retrieval.
assume that's probably the retrieval when you were referring to the subset of the ID you used.
Okay. I mean, that's the thing. When you run, let's say, a text search, you are trying to find a similar product. So obviously, the kind of the local search would be like try to find all the nodes that start with Mac, and then expand from those, and then try to pass that to the LLM to try to figure out what the question was asked. If the question was very vague, you would obviously need to build a pipeline that will kind of say this is vague. We cannot kind of determine with the quality that this is what you asked for. But still, the text search should handle, for example, that case, and that's a good question. Yeah, and we have more questions, or no, as far as I can see. So, any last questions here? Looks like we are good. Thanks, Russell, for taking the community call. Thanks everybody for coming to the community call. There is in 2 days we'll have a new community call with Capitech. They will talk about protecting their clients with the Graph Database. You should definitely subscribe to that event. It was nice talking to you, and thanks for the presentation, Russell.
Thank you very much for having us.
See you. Bye-bye.
Thanks a lot, everyone. Bye.